Alright, so what I'm going to do in this video is show you how to work a two-sample t-test. I'll do an example from MyMathLab, and we'll work it on the Mintab Express software so you can see how the technology works as well. So let's give this question a look. This is from your homework. It's not really a standard question because it's not a word problem. They're just kind of handing you to summarize statistics and picking your brain as to whether you could pass judgment on this claim right here. So they say, okay, use the given statistics to complete parts A and B. Assume the populations are normally distributed. All right, so don't be fooled by that statement. The assumption of the variable being normally distributed is needed for the two-sample t-test, remember. So let's give a look. It says, test whether mu1 is greater than mu2 at the 10% level of significance. Okay. So remember this statement, mu1 greater than mu2, that is an inequality statement, which means that it's for the alternative hypothesis. Remember also another way to say that is to say that mu1 subtract mu2 is greater than 0. Okay, so let's go ahead and look at the part A here, which says, identify the null and alternative hypotheses. All right, so remember the null hypothesis, its form has a condition of equality. So if you look at the multiple choices, it looks to me like choice A has a equality for the null, as does D. B and E don't. C has an inequality. Letter F has an equality. Okay, but we need to pick so it's going to be either between A, D, and F. We need to pick the alternative that has a greater than symbol. And as you can see, that's right here in letter A. So remember, for the alternative hypothesis, some books use H1, some books use HA, some books mix, so this is the alternative here. Alright, so it looks like it's going to be choice A, so let's give that answer a quick check. Okay, fantastic, great. Alright, so they want the testing statistic. Alright, so remember, I gave you templates for all of the hypothesis tests that we've covered, and those templates, they really summarize the entire procedure for hypothesis testing. For example, it has, it shows you where you can state your hypotheses, summarize your data, write down your critical value, make a decision on what distribution you're using. You could mark up your decision rule on a picture, crunch the testing statistic, which is what this question is asking you to do. So the formulas are on there. And the templates have places for passing judgment on the null, and then of course coming up with your final conclusion. It's a lot of information on one page. When you're using technology, obviously you don't need to do all of those steps, and you've experienced these steps already. So we're going to go ahead and use the technology here. So let's go ahead and use Mintab Express to calculate that testing statistic. So in Mintab Express, the menu items are up top, and here's the two-sample menu, which is where the two-sample t is, and it's the very first one. Don't get confused here with this paired t-test. That's actually week 9 material. So I'm going to go to the two-sample t here. And the first thing it picks your brain about is, what are you going to give me? That's what it wants to know. Both samples are in one column. No, we don't have data in our columns. The question gave us summarized statistics. So I'm going to pull down that drop menu. Oh, here we go. Summarize data. All right, so let's go ahead and type this in. So you can tab across to make this go a little faster. By the way, notice how different the sample standard deviations are. MyMathLab, when you're doing a MyMathLab question, the assumption is that the two-sample t-test you're doing is for unequal variances. If you wanted to do a question where it was equal variances, in other words, where you were pooling to find a pooled standard error, the question would tell you to do so. It would say, it would say pool your data, or it would tell you to calculate, assume equal variances and use pooling or something like that. But you can see, by the way, how different these sample standard deviations are. All right, so after you get the data in, you got to go to options, and this is where you put in the confidence level or alpha level, where you select your alternative hypothesis and whether or not you're going to pool. All right, so you can see the difference here. We got to change that because we have a right-tailed test here. So I'm going to switch that to a right-tailed test. The confidence level, as you can see, well, 90%, which is 10% alpha. So I'm going to type this as a 90%. And I'm going to leave this box unchecked because the assumption of equal variances is not being given to us in this question. All right, so once you have your data in and your options all set up, there's another menu item here, as you can see, for display, but these are grayed out, as you can tell, and they're only active when you have raw data, which we don't. We have summarized statistics, so we're not going to go calculating box plots using these summarized stats. All right, so once these are set up, go ahead and run the hypothesis test by clicking OK. All right, and it even tells you right here, equal variances are not assumed for this analysis, because remember, when you assumed unequal variances, you're using something called Welch's t-test. All right, so here's the summarized statistics. That's what we gave it, obviously. There's the standard error, sigma over radical n, or a modified version of it for a two-sample t-test. Here is the 90% lower bound for the confidence interval. But most importantly right now for the hypothesis test, this is what we're looking at. All right, so here's the null and alternative hypotheses, as you can see. There's the critical, not the critical, this is the testing statistic. They call it t-value. We just call it TS for testing statistic. There's the degrees of freedom calculation, and here's your p-value. All right, so it looks like the testing statistic is 2.70. So it says round your testing statistic to 2 decimals. All right, 2.70. Check my answer. Nice work. Thank you. All right, so determine the p-value. Okay, here we go. It says 3 decimal places. All right, so round this p-value to 3 decimal places. It looks like it's going to be 0.006. So 0.006. Okay. Good job. All right, here we go. State the conclusion. All right, so remember how the game works for hypothesis testing. When you're using, testing statistics and critical values, you would need to now go to the t-table and get the critical t-score and compare that critical t-score with this 2.70. But, when you're calculating a p-value, you don't have to worry about the whole critical value testing statistic scenario. All you need is this one number. This p-value, which is 0.006, which, by the way, if you take that decimal, move it 2 places to the right, that is 0.6%. So remember, you make a comparison with your p-value and alpha. The alpha level, the level of significance, is 10%. So when the p-value is smaller than the alpha level, we reject the null hypothesis. If the p-value were greater than the alpha level, then we would fail to reject. So notice, first of all, since the p-value is smaller than the alpha level, we are going to reject the null hypothesis. So if I go back to my hypotheses, you could look right here, or you could even go over here, in the Mintab output. We are rejecting the null. So write the statement that mu1 is equal to mu2. That is getting rejected. That means you are accepting this claim down here, which is the alternative hypothesis. So what are we accepting? I'm accepting that mu1 in fact is larger than mu2. The population mean for group 1 is greater than the population mean for group 2. All right, so first of all, I'm going to come down here. Letters A and D say the phrases do not reject. All right, so it's not those choices. It's either A, B, or C. So we know it's going to be reject. And letter B says there is not enough evidence to make that conclusion, and letter C says there is enough evidence. All right, so that's what we're looking for here. Reject the null hypothesis. There is sufficient evidence at 10% alpha to conclude that mu1 in fact is greater than mu2. All right, so obviously using your software in Mintab really does speed up the process. Can you complete the whole templates that I've given you? Of course, and I encourage you to do so. Whenever you learn a new hypothesis test, I encourage you to print out the templates and fill the templates out completely so that it aids in your overall understanding of the topic. But at the end of the day, when you're using Mintab Express or a TI graphing calculator, that has this testing procedure as well built into it. Your TI graphing calculator. Obviously we're getting a p-value method here. All right, so if you have any questions, feel free to shoot me an email. Hope this helps.